Hey everybody! Today's video we're going to talk about VMC on AWS. I have a couple workloads, well I only have a single workload in the VMC environment that I'm going to show communication over the ENI to the connected VPC as well as to other VPCs using a VPN attachment. So let's get started. So on this first slide you see here, this is mainly focused on the AWS side of things. I have three VPCs, VPC A, B, and C. Each VPC has two availability zones, one for the public subnet and the other for the private subnet. The public subnets are connected to the IGW, which allows us to have access to those VMs from the internet. I went ahead and deployed a transit gateway and did the VPC attachments for those, and then updated the routing tables for each subnet so it can be aware of where to route the traffic to. So in this case here, the 172.32.0.0/16 is going to get forwarded to the TGW, the transit gateway here. Same thing with the 33 network. So they all can communicate with each other. I also deployed a VMware single host SDDC instance. And during that deployment phase, I associated with the VPC-C as a connected VPC, which went ahead and established the cross connect for the ENI. And as you look at the table on the bottom right here, this private subnet is our main route table. And during this deployment phase, it went ahead and added two additional routes on that route table. The 10.2.0.0/23 network, which is our infrastructure up here, and the 10.100.111.0 network, which is our compute network up here. The transit gateway route table looks like this. It just has the subnets from each VPC in it with their unique attachment as well as the VPC associated with it. So it can forward the traffic to the appropriate VPC. Now routing is one thing. We also have to allow access inbound, and with AWS you do that via the security groups. In this case, I created two security groups for VPC-A, one for public and one for private. The public allows me to SSH into it from my home office, while the private allows access from the public subnet into the private, as well as it allows access from VPC-C into the private. Similarly, I did the same thing for VPC-B private security group, allowing traffic from VPC-A and C and the workload VM in VMC. And finally, we have our VPC for the public security group as well as the private for VPC-C. And the same thing, allowed access into the public so I can SSH into it and allow it to be able to ping the VM workload in VMC as well as communicate with the other VPCs in the environment. So with the security groups in place, now we can perform ping tests, right? We can ping from VM2 to VM3, going over the VPC attachment into the transit gateway, as well as VM2 to VM5, VM5 to VM3, and VM4 to VM2, as well as VM4 to VM3. So what I'm going to do now is we're going to switch over. We're going to perform some of these ping tests regarding the AWS specific stuff. So let me go ahead and maximize this. Actually, before we get into the ping test, let me show you the AWS console. So here's our three VPCs, VPC A, B, and C. Here's our subnets, our private A, public A, private B, private C, and public C. So if I click on private C, you can see, or actually go to route tables, sorry. If I click on private C subnet, you can see it's the main route table. So once the SDDC instance was instantiated, it automatically added these ENI connections here for me. And we'll talk more about this process in the next slide. So now we'll scroll down. We'll look at the transit gateway real quick. So we deployed our transit gateway. We have our attachments. So we have three VPC attachments. for the respective VPCs. And then we also have a VPN attachment, which we'll talk about later. So if we look at the route table, we can see that the routes are propagating between the VPCs. So they'll be able to route traffic to them. So if we look back up at our route tables for each of these private subnets, you'll see that in order to get to 32 or VPC B or C, it needs to go through the TGW, which is the transit gateway. Same thing for private B, and similarly for private C, go through the transit gateway. Now the public, any traffic that it doesn't recognize is going to go through the IGW for the public interface subnets. Same thing here. And then we can quickly look at the EC2 VMs that we are using for this demonstration. So we have a total of 5 VMs, 2 in VPC A, 1 in VPC B, and 2 in VPC C. So VPC VM1 and 4 are the public VMs, and then 2, 3, and 5 are the private VMs. And we can look at their security groups real quick. Security groups, when you first instantiate the VMware SDDC instance, this is the default rule that it gets created. You have to allow traffic from your connected VPC in through that. But we'll discuss that in more detail. But if we look at our private A security group, we're allowing traffic inbound from VPC C, private B, again, VPC C and A, and in private C, we're allowing VPC A in the public. So let's jump into some ping tests. So let me exit here. We're currently connected to the public. So let's bring this over here. So we're currently connected to VM4, 9220. So 9220. And let's do a ping test to its neighbor, 172.33.24.53. You can see we can communicate with that. Let's also ping the VPC B private VM, VM3, ping 172.32.19.232. And you can see we have communication there as well. And finally, we'll do another ping test from the VPC C public to the VPC A private, so VM2. So VM4 to VM2, ping 172.31.16.22. And we have communication there as well. Awesome. That's routing for the AWS environment. So let's just jump back in. So we just validated we can communicate between the different EC2 instances in the different VPCs using the transit gateway. And now we'll talk about VMC routing. Right now, we're going to just focus on routing via the connected, the cross ENI, Elastic Network Interface. In order for this to occur, there's a couple things we need to do. One, we need to create the firewall rules on the VMware side to allow access via the VPC interface. So you can see here, this little box is highlighted. This T0 router has all of our interfaces connected to it, right? So we have our VPN interface, our direct connect, our internet interface, our VPC interface, and whatnot. And then we have all uplinks as well. So that's the first spot where we're gonna need to take action to, right? We also need to allow action from an AWS side of things, allow the VPC, connected VPC subnet access to traverse the ENI back into the VMware environment. So that's what this security group here is for. Finally, we have one more as well. We have a public security group and a private security group. The public allows me access in from my home office, but it also allows inbound traffic from the VMware environment to come in to the security group and communicate with VM4. And then lastly, we have the private security group, which allows traffic from the public VM, VM4, to communicate with VM5, and also the VM in the VMC instance to communicate through the ENI back in to VM5 as well. So the first rule we enabled, we want to give this VM internet access so it can get all its updates and whatnot. We create a VM with the source being the VM itself, destination being any, and we're applying it to that internet interface. Now, if we want to get communication from that VM down the ENI, we need to use the VPC interface. And as you can see here, the next two rules, the first rule here in green is allowing outbound access from the VMware environment down towards the AWS connected VPC over the VPC interface. And then the second rule is allowing traffic from the VPC prefix back in to the VMC environment. So this connected VPC prefix, this is nothing more than just this 172.33.0.0/16 network. So once those rules are in place, this VM can communicate with both private and the public subnets. So we'll jump over. We'll do a demo of that as well. So let me clear the screen here. We're gonna first ping the public interface, which was 172.33.9.220. And we can ping that from the VMware environment. And we're gonna ping 172.33.24.53, which is the private subnet on the connected VPC, and we can communicate. So now if we open up our SSH console and we'll ping the workload in VMware, we can see we can communicate to it from the public VM, VM4, and we'll SSH into VM5 here, and we'll do a ping test to that same workload. Oops, not 1,000. 100. And we can ping that as well. So we have communication over the ENI working successfully. So that's pretty straightforward as far as connectivity. I wanted to provide a quick overview of the SDDC environment here. So we have a single host. As you can see here, our test VM is sitting in the compute resource pool. If we go to network and security, this is where we can configure access into the vCenter environment, as well as configure VPNs, configure firewall rules. So first things first, we'll look at the connected VPC. So this is the VPC that's connected to the SDDC instance. And we can validate this by one, the account number, but also two, these other IDs. So the VPC ID and the active ENI is right there. So if we go back to our EC2 instances and go over to the VMC, the network interfaces, we can see VMware has created a bunch of ENIs. One is only active at any given time, but in a production environment, let's say this host fails, VMware will automatically select another host to activate the ENI on, and so the routing could continue to function as expected. But in this case, we have this one here. This is the default security group that it's using for that VPC, and we can look at the inbound rules. So we're allowing access from our VPC to traverse that ENI. And what else do I want to mention here? Oh, yes, another thing to keep in mind here with default route table, if I change this, let's say I want this one to become the default and I set it to become the main route table. If I create a new segment in VMC, it's still going to reference the original one during the creation, because all the API calls are going to happen for the original main route table. So in this case, the private subnet C. So I can show you the routing table, how it would look. Here you see we have this 10.100.111.0/24. I go back into the VMC environment, go to segments, and we'll just create a test one. We'll say 10.100.112 1/24. We click save. As soon as I click save and switch over back to the routing table and refresh, you can see that this route was automatically added to that private subnet. Now, if we look, we notice that this is not the private and it didn't automatically add it. So you want to keep that in mind when you're in the production environment. Keep track of your route tables on which one's the main, because any subnets created in a VMC environment will automatically get added to the main one, as you can see here. And if we go back into the VMC environment, select that one, delete, and jump back over, refresh, you can see it's gone. So it's pretty instantaneous. All right, well, let's jump back into the slide deck. We'll look at the VPN connectivity options. So here's our diagram again. This time we're going to be focused on creating a VPN from the VMware environment to the transit gateway. The great thing with the transit gateway and the NSX Edge appliance, they support equal cost multipathing. So if you had a requirement for more throughput, you could bundle multiple VPNs together in order to accomplish that. But in order to establish a route-based VPN, you have to set up a virtual tunnel interface on the VMware side as well as on the AWS side. And we'll go over that once we talk about this diagram. Once you have the VPN established, it will learn the routes from the VMC environment, as noted down here with these last two. And from an NSX advertised routes perspective, you can see NSX is advertising those routes, 2.0.0, as well as the VM that we've been using for these demonstrations, the 10.100.111 network. And it also learned routes from the AWS environment. So you can see we learned our 3 VPC subnets. To allow communication from our workloads over the VPN, we do have to create additional rules in the NSX compute gateway. We just need to create access from the VM to the VPC A and B environments, as well as from VPC A and B in to the VMC environment over the VPN tunnel interface for both. Once we do that, VMs in the VMware, the VMC environment can communicate with VM2 as well as VM3. So we'll jump into the demo and demonstrate that as well. So we're back into our VM and the VMC environment. Actually, before we do the ping test, let's talk about how we establish that VPN. So we'll start with the AWS side of things. We first created a customer gateway, and we used the NSX public IP address, public VPN address. So if we go to network and security and click on overview, right there, we can see the VPN public IP address. We just use that public IP address for our customer gateway. So we just gave it a name, select dynamic. We use the default 65,000 because that's what NSX and VMC uses. And we just put in our public IP address. Once you have that done, you can go down to your transit gateway. Gateway attachments and create a new attachment. And this attachment will allow you to select the transit gateway, select VPN, select your customer gateway, and we'll just leave everything else defaults and dynamic, of course, and then create attachment. Once you do that, you'll see this attachment become available. The VPN attachment right here become available. And when you look at the route table, you'll see routes propagating. So this is the routes from our VMC environment. If we go back to our site VPN, you can see it automatically creates a site VPN attachment. If we look at the tunnel details, these are the 2 public IP addresses that AWS gives you in order to establish a redundant connection. In this example, I only set up 1, but I could theoretically set up the second one by downloading this config, selecting generic, okay, refresh the page. download config, generic, download. And you can see here that it provides all the configuration we need to set up VPN tunnel between VMC and AWS. So once we take that information, we'll take it over to VMC side, go to VPN route based, and we'll expand this and we'll input the details here. As you can see here, I already established that connection. I have public IP address that AWS gave me, and we can actually view the routes that are being learned. So these are advertised routes from the VMC side, and these are the learned routes. So now if we go back and we try to ping VM2, which was ping 172.31.16.22, we can ping it. And if we try to ping VM3 19.232, we can successfully ping that as well. And if we jump back into these AWS VMs, so we'll SSH into that. So we'll SSH into, no, not ping, SSH into VM2, and we'll ping 10, 100, 111, 100, and we can ping it. So that VM can ping the VMC workload through the VPN attachment on the transit gateway. And we'll do that also for VM3 on VPC B. So we're connected to VM3 and VPC B, and we'll do a ping test to 10, 100, 1,000. And we can communicate. And finally, we'll look at the firewall rules that allow the communication. And it's going to be these two rules here. AWS TGW to VMC over the VPN interface, and then the return or the outbound from the VM to the AWS subnets over the VPN. And then now we'll go into the last use case where I did a POC for a customer, and they had a particular use case they wanted to test, where they wanted to leverage the VMC E&I cross connect and route traffic from their VMC environment through the VPC-C connected VPC over to the transit gateway, utilizing both the 25 gig throughput as well as the 50 gig throughput to other VPC environments. So they had so say VPC was their backup VPC where they were doing all their backup for their infrastructure. They wanted to route traffic through the E&I because it had more throughput than the IPsec VPN tunnels. So for example, workload in VMC trying to communicate via the E&I to VPC-B or VPC-A. This is known as transitive routing and is not supported by AWS. So that unfortunately is not a supported deployment. Now, in this situation, if they wanted more throughput, they can leverage transit gateway and leverage the equal cost multipathing to increase their bandwidth. All right. Well, that's going to wrap up this presentation. Hopefully it was helpful. If you have any feedback or questions, don't hesitate to reach out. Thank you.